be observing Ms. Fuller's 7th grade science class this month. Bear with us, it's homecoming week. There's been a lot of distractions. We're all dressed to participate in the activities, but I hope you enjoy the lesson.
No. Okay, we've already covered this, guys. Justin, you have a question?
I have this one.
Okay, guys. Justin, I may not have told you this, it's your new, but whenever you don't have your supplies, you just grab one out of that and sign on it. Okay, guys, when you're finished with your bell ringer, pull it out of your binder so you can turn it in.
Wait, is it Friday?
Today is Friday. Alright.
Wait, I think that's... Wait, it's all done.
Listen for your name. Justin.
Here.
Abby.
Here.
Christina.
Here.
Natalie.
Here.
Dayton.
Here.
Jocelyn. Nathan. Chelsea. Josie.
Here.
Mason.
Here.
Presley. Yes, Dayton.
Oh, we're talking about living things. Are we talking about like cells and stuff, or was this like humans and stuff?
Okay, remember this is a review. We covered this last week. There's certain, I got it in. There's certain characteristics that all living things have to make sure, that tells you that they are alive. So just pick 4 of those. You have your notes in your binder you can refer to if you need to. Do you have your Where's your binders? Back here? Yeah. Yes. Alright. Get your bell ringers out. I will take them up. You have your bell ringers for the week, girls? Bell ringers? Bell ringer.
Keep the project management skills.
Alright, while you're turning these in, somebody raise your hand and tell me one thing. Presley.
They have to have DNA.
Have to have DNA, genetic information. Does that mean it has to have a nucleus in the cell? No. Abby.
Cells.
Has to have cells. Presley.
Have to grow and develop.
Grow and develop. Mason, you know one?
They have homeostasis.
Okay, they conduct homeostasis. Alright, what else? One more. Christina. Response to stimuli. Okay, so this was just a good review. So we hadn't talked about it anymore this week. You need to open your books. Page 46. They have everybody's bell ringer?
Let me get out.
Your textbook, open it to page 46.
Macromolecules.
Macromolecules.
Then
Alright, so what we're going to talk about today are the 4 main macromolecules that are also found in all living things. One second.
Wait.
46. we're going to break this down and graphically organize the information that belongs to each one of these macromolecules. So have any of you ever heard someone say it's kind of a trendy fad diet, even though it is more than just a fad? You heard someone say that they're counting their macros. Anybody?
I have.
You have. This is what they're talking about. So you consume these things, or we do because we don't make our own food. And each one of them plays an important role in how we maintain our own health. So what is in each one of these? Let's start with carbohydrates. So if you look on in your book, we're just going to kind of summarize and skim through the book and then break it down on our graphic organizer. So I'm going to fill it in on the board with you as we go along. So first we have carbohydrates, and most people just call these carbs, right? So in your book, this is on the bottom right on 47, carbohydrates. So the first thing they want you to tell them is what elements are in carbohydrates. So look through that section, see if you can find what elements. So when we're talking about elements, we're talking about the ones that are on the periodic table, that are on my ceiling if you need to reference them, okay? So like the main things you're going to be looking for are carbon, hydrogen, oxygen, nitrogen, phosphorus, those main ones that are in organic material. We're talking about living things, right? All right, Dayton, did you find one?
What about sugars? Is it?
Okay, sugars, we're not there yet. Sugars is a little bit more complex than the elements. Nathan?
Wait, is it talking about this?
Bottom right, where the paragraph about carbohydrates,
There's nothing about.
it doesn't
No.
tell you in there?
There's
No.
nothing about it.
Okay. Well, let's back up then. In carbohydrates, the elements, and I'm going to abbreviate these, okay, so you can also as well. So you have carbon, hydrogen, and oxygen to start with, okay? So carbon, hydrogen, and oxygen are the elements in carbohydrates. Now the next one are what we call the train cars, okay? So I want you to put a little train car right here to help you remember that. The monomers are what make up the big long chain, right? So this is like a train car that makes up our train. Our train is the main macromolecule. The train car is your monomer. So if you want to write up here to the top, this would be the polymer. And what does the prefix poly mean?
Many.
Many. So there's many of them put together. So there's many train cars in your train, right? Monomer, what does mono prefix mean?
One.
One. So there's one. Each one of these makes up a train car in the train. And we'll talk about that a little bit more in just a minute. So let's go down and continue with carbohydrates. So look in your section there. Do you see anything that tells you what the monomer is for carbohydrates? Christina? Monosaccharides, yes. Okay, we see that prefix again. One, saccharide. Okay, if you can't see this very well, it's in your book as well. Or if you don't know how to spell that. Monosaccharide. Let's see, about middle of the way. Can't find it either? Nope. Okay. Monosaccharide, MONOSACCHARIDE.
Oh, we've said this.
We have, yes. Jocelyn, can't see? Okay, you want to scoot up here? Sit up.
full seat.
Okay. I'll let you look on this one. Okay. carbohydrates do for our bodies? Christina?
They're the main source of energy.
Energy source, yes. And can you think of an example of a carb that you might eat? Bread. Is that what you're gonna say?
Eggs.
Bread, pasta.
Potatoes.
I just
Boiled eggs. Candy.
No, not quite boiled eggs.
Coffee. Fruit.
Bread, pasta. We'll stick with those. Okay, this is why your parents might have told you sometimes to eat spaghetti the night before a game or something like that. It's because it gives you a lot of energy.
I love spaghetti.
You love spaghetti. All right, next, lipids. So lipids section is right above the carbs on page 47. And the elements that are in lipids are the same as carbohydrates. We have carbon, hydrogen, and oxygen. Okay? Carbon, hydrogen, and oxygen. I don't know that it tells you that, but you'll need to know it later, so. And the monomers, or our train cars for lipids, are fatty acids, yes. I'll put another train car here to remind you. Who can tell me what the lipids do? Justin,
I raised my hand.
you didn't raise your hand. Christina, store energy? Anybody have anything? Okay, that provides stored energy. Is that what you're gonna say?
It says that they protect the cells.
Okay, both, right? So they store energy. How do they protect the cell? What is our membrane made of?
Like, yeah,
Yeah, they're waterproof covering. So these are lipids, they're fats, they're oils, and fats and oils, do they mix with water? No, so they're the perfect consistent or perfect composition to protect the cell. And I'm gonna put membrane in parentheses there. All right, so I've already given you an idea of what these are. What would be an example that you would consume or eat? Butter.
Oils.
Yes.
Spices.
Fats. Okay. Ready, caught up? Ready to move on to proteins? Okay, proteins. Proteins are on at the very top of the page on 47. And we have the same elements, but we're adding nitrogen. Carbon, hydrogen, oxygen, and nitrogen.
Sean.
Do you remember what our monomers are, Presley? Amino acids. JC.
Wait, draw a train card.
Yes, draw a train card. Just to help remind you. Do you remember, or can you find what the function of the proteins are? What do they do for our bodies?
Give them energy.
Protein? Hang on, let JC have a chance, please. Transfers, okay. Proteins have a lot of different hats that they wear. The main thing is that they're involved in the chemical reactions. So they control and that's a broad description, but they're involved in communicating and transporting. So we'll just say chemical reactions because that covers a lot of different things. And how do you consume, or what's an example of something you consume that has a lot of protein? Meat, Justin.
Peanut butter.
Granola bars, what do granola bars have in them that would have a lot of protein?
Like peanuts,
Nuts.
Nuts? Yes.
peanut butter,
Meats, nuts,
eggs.
eggs. Yep. That would go under meats.
That's what I was thinking on the card. I was
Yes.
thinking of eggs.
Yep. You got ahead of yourself. Anything else? That's pretty much, that covers it, right? So if you were a vegetarian, where would you get your protein source? You didn't eat meat.
Salad.
You could do nuts. What's another one?
Salad. Isn't that? Eggs.
Eggs. What about beans?
Oh,
Yeah.
Yeah. Okay. Last one, nucleic acids on the left-hand side on page 46. You have another carbon, hydrogen, oxygen, nitrogen, phosphorus. That's right, chomp. See the acronym there? Chomp. Chomp. Those are condoms. Chomp. Chon. I know that's hard to say. Carbon, hydrogen, oxygen, nitrogen, and phosphorus. Nathan.
Why does song sound like a Chinese brand or something?
I don't know. It's just the elements that make up nucleic acids. All right. So our train cars. What are they for nucleic acids?
DNA,
Hmm.
Nucleotides.
What did you say?
Nucleotides.
Nucleotides. Nucleotides are our train cars or our monomers, if you want to call them what they actually are. Nucleotide.
I like that word.
Nucleotide.
I don't know, I heard nucleic acids, I like that word. Nucleic.
Yeah. Mason, can you find in that section where the function is or what the function is?
No,
No?
I can't.
Second paragraph. What do they do for us? Help them out, Justin.
They contain genetic information.
Yes, contains the genetic information and it transmits them as well. Stores and transmits genetic information.
That bothers me.
Out of the line.
Yes.
I'm sorry. All right, so Abby, you already said our example. What is it? What'd you say?
What did I say? Peanut butter?
No. You said it for this one already.
Oh, the DNA.
Yeah, DNA and RNA.
Say O.
Deoxyribonucleic acid.
Trans.
Huh?
Does that say O?
And
Oh.
DNA and RNA.
No, I mean in the middle.
This?
That's
Oh,
different.
and.
Oh.
This membrane part is killing me. I have to get it smaller.
Okay, so I'm going to show you a quick little video that explains it just one step further as far as our train cars go. And it gives you kind of just a little bit different perspective. So just listen. And we're going to do a little activity with our monomers in just a moment. Everybody get all this? Nope. No?
No, I'm. Do we put this in a binder?
Do what?
Do we put this in a binder? Just a box so.
Just keep it up for the moment. We're going to use it in just a second.
Wait, isn't it 12?
11.
Oh, wait.
Wait.
Okay, listen up.
Yes, I'm talking to you. Let me explain all the nutrients that are in that cheeseburger. That cheeseburger contains polymers, which are large molecules made up of smaller molecules called monomers. Think of this train car as a monomer. We can link monomers, even different kinds, together to form a long molecule. In this case, the train, which is a polymer. There are 3 polymers needed by the body, which are carbohydrates, lipids, and proteins. The first polymer, carbohydrates, are made of small molecules called monosaccharides, which are simple sugars, such as glucose and fructose. These monosaccharides can be linked together to form polymers, such as sucrose or table sugar. Since only 2 are linked, it is called a disaccharide. Many monosaccharides can be put together, such as chains of glucoses forming starch found in plants. Since many were put together, it is called a polysaccharide. There are other polysaccharides. When glucoses are branched like this, it is called glycogen, which the body stores in the liver. Other glucose chains form cellulose in plants, also known as fiber, which humans cannot digest. Fiber is important to eat because it helps food move through the digestive system and can lower your cholesterol. The main function of all these carbohydrates is to provide the body with energy, and help make some cell parts too. The second polymer, lipids, also is used for energy, but in the long term. Lipids are made using fatty acids. If a fatty acid has all the hydrogens it can possibly fit, it is called saturated. These are solid fats like butter, which can raise your cholesterol. If the fatty acid has a double bond, it is called unsaturated. These are liquid fats like oil and can even lower your cholesterol. When 3 fatty acids are linked to a glycerol molecule, it forms a triglyceride, the fat used for energy. If you eat too many of these, the body stores it as body fat, making you bigger around the middle. 2 fatty acids added to a phosphate group form phospholipids that join together to make your cell membranes. Another lipid is cholesterol, naturally made by your liver. It is involved with cell membranes in making hormones like testosterone and estrogen. Too much, however, has negative health effects. The last polymer, proteins, build body structures like muscle and cell membranes and act as enzymes to speed up chemical reactions. Proteins are made from combinations of 20 amino acids, which all differ based on this side chain. The amino acids can be linked together using a peptide bond. Many amino acids linked together is called a polypeptide, which can be folded and added to other polypeptides to form complex proteins like hemoglobin, which carries oxygen in your blood. Proteins speed up reactions by acting as enzymes, which can help break molecules or help build them as seen here. That cheeseburger is filled with carbohydrates, proteins, and lipids. Chemical reactions during digestion break them apart into monosaccharides, fatty acids, and amino acids, which can be used by the body to build the carbohydrates, lipids, and proteins that it needs to function. The chemical reactions used to break the molecules, plus the ones used to build them, are collectively called your metabolism. Something to think about as you eat that burger.
Thanks.
Okay, so flip your papers over.
Is that why they call it fatty acids?
Huh?
Is that why they call it fatty acids?
Does it make you fat?
Mhm.
No. Alright, so look at your paper that you have on the back side. So now what you're going to do is you're going to build your own train cars, okay? So you're going to draw in, so your train cars for your nucleic acids look like this, the hexagon, I think that is. And you're going to make your own train car using these as the shape they are. So amino acids, you're going to have to decide which one they go to. Fatty acids, which one do they go to? Monosaccharides, okay? So if you need to flip over and use what we just talked about, that's fine. I'll be walking around, but I want you to make your own train cars, and then you need to tell what the functions are as well. Understand? You may have questions?
Do we start?
Huh?
Do we start?
Yes, start now.
Can I? What do
So-
you mean make a train car? Oh.
Can we draw them?
Yes, you're drawing it.
We
So
draw
for
the shape.
example, listen, in your first blank, what is it, proteins? It says monomer, okay? So we're not gonna say out loud because I want you to do this on your own real quick, but we're gonna talk about it as soon as you finish. So you're gonna have to decide which one of these monomers goes with proteins and draw a chain of them. You're making a train car. I mean like a train with the train cars, okay? And then write the function over here on the right.
From those?
From those. Or from your notes on the other side if you can't see that. Alright? It's not anything complicated. Don't overthink it. You're just drawing the shapes based on what you see that they look like on the board. And I'll make this a little bit bigger for you.
Well, that's amino acids.
Four. That shows all of them. So that shows you what the shape should look like.
Wait, are those all the ones for this?
There's one.
There's all four.
Wait, there's,
So you're making a line of monomers. That's all you're doing. Yes.
wait, there's only one going in each box?
Yes.
Oh,
Only one shape goes for each one.
wait, is the
You
order
don't
matter?
mix the shapes. No.
I'm confused. I don't know.
Okay. Look, see which monomer goes with proteins.
Amino acid.
Okay. So which shape is the amino acid?
Weird.
Okay. So make me a train of diamonds. That's all you're doing.
I don't understand this either.
No, just a chain. Just a double box. Okay, proteins. Which one up there, which shape goes with proteins? Which monomer is for proteins? No. Oh, your monomer. There's your protein. Okay, so which shape on the board is an amino acid? That's what you're drawing, a chain line.
Just one shape?
In the whole chain. That's the way that they're shaped in reality. I mean, not in a diamond, but they're in a chain.
How many do I do?
On that side. There. Do you have your paper, Chelsea?
Just how, or, this four.
Chelsea, you have your paper? Can you put that away right now, please?
Do we like the functional one?
Yes, put the function, please.
How many do I do?
Just as many as, that's plenty.
Like two.
They're just getting a visual of what these actually look like.
Wait, what?
Hmm?
Do we just draw a shape?
Yes.
Oh,
Well,
No. So, I mean, guys, in reality, they're not hexagons and triangles or diamonds or anything like that, right? But they make this train-like shape with the bonds like you saw in the video, okay? It actually was, some of them actually are in a hexagon shape with the different elements, the carbon, the hydrogen, the nitrogen. That is the structure that they actually make. But I'm just trying to get you to visualize and think about how these come together to make a polymer.
so,
Yes.
can we do like 4 or 5 of them?
Yes, that's fine. 4 is fine. 5 is fine. Then just write the function.
I have a question.
Yes, ma'am.
This one is function. Wouldn't it be the amino and iron resource?
Looks good to me.
Because it's not protein.
Okay.
Protein is not the.
Well, you have your notes you can refer to. Right? Am I on your way? Yes. Did you finish?
Yeah.
Okay. Just hold on to it, and we're gonna give everybody else a few more minutes, and then we'll go over it together.
Okay.
trains, guys, your polymers don't have to be perfect. Don't stress about how well you can draw. Yes.
What do you put in function?
What does it do? So here's your 4 options, or you can look back at
Wait,
your
what about the thing next to it, what is the function?
Yes, there